So in 2.4, we want to learn how to graph a sine graph and a cosine graph. And we're going to focus on certain parts of transformation. So we're going to move them up, down, we're going to reflect them, and then we're going to vertically stretch them as well today. So you're going to need out your unit circle to be able to do this. So pull that out. Okay, so we're going to make a table of values. We're going to write degrees in one column and the y values assigned in the other column. So if you look at your degrees there, and we're only going to do some of the basic ones. We're going to do 0, we're going to do 90, we're going to do 180, 270, and then all the way around is 360. And if you look at your y values for your ordered pairs on each of those, at 0 degrees, the sign of 0 there is 0. And then up at 90, on your unit circle there, at 90, the y value there is 1. At 180, your y value is 0. At 270, your y value is -1. And at 360 on your unit circle there, your y value there is 0. So those are kind of the basics. So I'm going to graph it out by degrees. And then, because most people can see degrees here, and then we'll do the radians as well. So 1, -1. So the t value, that's going to be what we're going to plot on the x-axis there, the horizontal axis, and then up and down there, that's our sign there, our y value there. So let's plot this out. So at 0, 0, we have that. At 90, we have 1. At 180, we have 0. At 270, we're at -1. At 360, there we're at 0. So we can simply connect a nice smooth curve. It's not pointy, it's rounded, and then that's a periodic function, and we could keep going. We could add 90, we're at 450, add 90, we're at 540, and we could keep the graph going. And we could also go backwards as well here. We could do -90, -180, and so on and so forth. So coming this way, you can see the pattern just continues to go. So this here graph here, the period of this graph, that's how long just one nice rotation of your graph there, one period of your graph there. In this case, with our sine graph there, it's 360 degrees. And then the amplitude is how far it is from this. There's a horizontal line that goes straight through this, and the amplitude is distance here and the distance down to here, and that's your amplitude. And your amplitude here in this case is 1. So we can also shift them up and down and left and right. We can vertically stretch them out. So now let's go ahead and let's do the same thing, but let's use radians. So unit circle there, we're going to go 0, pi over 2. We've got pi. We've got 3 pi over 2. And we got 2 pi. Sine is our y value, so 0, 1, 0, -1, and back around there to 0. So let's plot this one. And this is the one I'm going to be asking you to do this in. So you got pi over 2, pi, 3 pi over 2, and 2 pi. When you graph these out, you're going to graph them out in radians. So it's 0, 0 is my first ordered pair, pi over 2, 1. We've got pi 0, we got 3 pi over 2, -1, and we got 2 pi is 0. Again, connect them a nice smooth curve there, and there's my sine graph. So if I were to talk about my period of my graph here, it goes from 0 to 2 pi, that's a distance of 2 pi. The amplitude, no different from your other sine graph there. Here's the line that goes straight through our graph there, and distance here would be 1. And distance here would be 1, so amplitude is 1. So now let's go ahead and let's do cosine. We've done sine, let's do cosine. So cosine, again, I'm just going to pick my same nice values I did before. 0, 90, 180, 270, 360. Cosines of my x values. So I've got 1, 0, -1, 0, 1. So graphing this one out, 1, -1, 90, 180, 270 degrees, 360 degrees. Let's plot this one. So starting up here at, this time it's 0, 1, 90, 0, 180, -1, 270, 0, 360 is up there at 1. Connect those. And again, the pattern just continues to repeat itself. If I wanted to put some more in here, I could definitely do that. -190, -90, -180. So plotting these, we could continue the pattern out. So this time, the period of my graph here, that black part of the graph there, it lasts from 0 to 360. So period of graph 360. Amplitude, again, I could put a nice horizontal line through there. And the amplitude here, that's just 1. Oops, that's not amplitude. There you go, amplitude. 1. And we could go here as well if we wanted to. So finding cosine in degrees, now let's go ahead and let's graph out cosine in radians, which is the one I'll be expecting you to do. So in radians, let's use the same nice ordered pairs, just the ones on the axes there. 0, pi over 2, pi, 3 pi over 2, and all the way around 2 pi. So now looking at the x values again, we got 1, 0, -1. At 3 pi over 2, we got 0 for our x value. At 2 pi there, our x value there is 1. So plotting that out, we've got pi over 2, pi, 3 pi over 2, and 2 pi. So at 0 we got 1, pi over 2 we got 0, pi we're down at -1, 3 pi over 2 we're at 0, and at 2 pi we're up there at 1. So connecting those. And again, if we were to identify the period of the graph there, it lasts from 0 to 2 pi, that's a distance of 2 pi. Amplitude, again, looking here and going up here, going down here, it's an amplitude of 1. That's how far it is, it's the distance of 1. So we are going to be looking at transforming the sine and cosine graphs in terms of radians. So the ones we're going to look at today is we're going to look at the amplitude. The amplitude here, so the generic formula here, I'm going to show it to you. So y equals a sine times k parentheses x minus b and then plus d. Sometimes they put the d out here in front and they'll do d plus a sine of k times x minus b. So sometimes over there it might be a negative d plus. So same thing with the cosine here, they might put the d over there in the front, so it might say d plus a cosine k times x minus b. So the ones that we're focusing on today is the a and the d portion, all right? So the a is your amplitude here. So if there's nothing there, it's considered a 1 out here. So like the ones we just graphed out, we graphed out 1 sine t there, or just sine t there. So our amplitude happened to be 1. And that will also determine how we're going to vertically stretch or shrink it. It's also the largest value of the functions typically here. A there is less than 0, it's going to reflect over the x-axis, the horizontal axis. So we'll just flip it over. And then D is going to shift it up or down D units. And we'll graph some of those out. And that will happen for the sine graph as well as the cosine graph, the same formulas for that. So let's go ahead and look at this one. We're going to graph out y equals the cosine of x. And you can do these on separate little axes if you want. You can put them on the same one if you want. It's up to you. I'm just going to put them on the same one, and maybe I'll just put only maximum of 2 on each one, because that way we don't get too confused. So we'll do it like this. I'll do 2 separate ones here. So again, when we're graphing these out, we're graphing these out in radians. I'm going to do it out to 3 this time, and I'll do the same thing here. We may not have to go that far, we'll see. Sometimes I don't go far enough because we got some movement going on here. All right, so graphing this first one out, I'm going to graph out just the basic y equals cosine x. So we said at 0 degrees there, just follow your unit circle. So at 0, your cosine there, your x value there is 1. At pi over 2, your cosine value there, your x value there is 0. At pi, your cosine there is -1. At 3 pi over 2 is 0. And at 2 pi, your x value there is up there at 1. So there is just in general, our cosine graph. That's this one. So I just graphed that one out, and then I want to show you how that changes. So now we're going to say y equals 2 plus the cosine of x. So what that means is each of these values that are right here, like that one there, you're going to go ahead and add 2 to that. So adding 2 to that, that just moves it up here too. And this sitting right here, just move it up to 1, 2, count. And then at -1 there, I'm going to move it up 2, so 1, 2. And then at 3 pi over 2, I'm going to move that up 2, so 1, 2. And then at 2 pi over here, we're sitting at 1, I'm going to move it up 2, 1, 2. And then I can simply connect those. So there is y equals 2 plus the cosine of x. So you can see how the d value, it moved it up. The whole thing, if you look at the red graph to the blue graph there, it moved the whole thing up there too. And I should be connecting my dots. There we go. So I'm going to do the same thing over here. I'm just going to quickly sketch out the cosine graph. So 0, 1, pi over 2, 0, pi is at -1, 3 pi is at 0, 2 pi is up here at 1. Just to kind of show us what happens. So now I'm going to graph out a y equals -1 plus the cosine of x. So what's this one going to do? It's going to move everything down 1 because there's a -1 on the outside there. So moving everything down 1, down 1, down 1, down 1, down 1. And now my new graph, this is y equals -1 plus the cosine of x. So I can clearly see that that's my ending graph there. So that is moving up or down. And then we're going to look here next year at amplitude. So we'll do that on the next video here.